G open dot f negative 2 is really the same as this, G of f of negative 2. So what we're going to do is I'm going to plug the negative 2 in for my f of x. My f of x here is x squared minus x plus 5, and my g of x is x plus 2. So f of negative 2 is going to equal negative 2 squared in parentheses minus a negative 2 plus 5. Well, negative 2 squared is 4, minus a negative 2 is plus 2 plus 5. So f of negative 2 is 11. And now I can replace my f of negative 2 with 11. So g of 11 equals 11 plus 2. We put the 11 in wherever you see x, and we get 13. And that's our answer. Okay? You deal with the f first, then the g. For 27, we have f open dot g 4, and that's the same as f of g of 4. My f of x is 3x squared minus x plus 5. My g of x is equal to negative x plus 7. So I do my g of 4 first. G of 4 equals negative, and there's a 4, plus 7. So g of 4 equals 3. Okay. So I replace my g of 4 with 3. Okay, let me just correct what I did here. Okay. So for f of 3 here, it's 3 squared minus 3 plus 5. You should probably put that in here. So the 3 squared is 9. So 27 minus 3 plus 5. And this is all what f of 3 is equal to. Okay. My f of 3 is going to equal 24, and 5 is 29. All right, for inverses. The inverse of f of x equals 3x plus 2. I've got to know that f of x equals y. And to simply get an inverse, we flip the x and the y. It's x equals 3y plus 2, and I solve for the y. Subtract 2 on both sides. X minus 2 equals 3y. Divide by 3 on both sides. This right here is the inverse. And that's an easy check. If I put 2 in for x, my y is 8. If I put 8 in for x, my y is 2. It should reverse the point. For number 29, we're doing the inverse of x over 2 minus 5, which is y equals x over 2 minus 5. We flip the x and the y. I add 5 to both sides, and then I multiply everything by 2. So 2x plus 10 equals y. And if we want to verify that, pick a number. 4. 4 divided by 2 is 2. 2 minus 5 is negative 3, so 4 negative 3. If I put negative 3 in for x here, 2 times negative 3 is negative 6, plus 10 is 4. It works out on both ways. If you want to determine whether something is an inverse of each other, this is what we're doing on 30. Is f of x equal to 1/2 x plus 5, and g of x equal to 2x minus 10, inverses of each other. And if they are, f of g of x should equal x then. And g of f of x should also equal x. So let's see if that happens. F of g of x. So f of 2x minus 10. 1 half 2x minus 10 plus 5. That becomes x minus 5 plus 5. That equals x. G of 1 half x plus 5. Well, 2 times 1 half x plus 5 minus 10. 2 times 1 half is x. Plus 10 minus 10, we get our x back. So I would say yes, they are inverses of each other. Because when you do a composition of them, you get x back. With 31, f of x equals 3x minus 1, g of x equals 3x plus 4. So, are they inverses? Let's see. If I plug f of g of x in, that means f of 3x plus 4. Well, when I plug that in, I get 3 times 3x plus 4 minus 1. Here we get 9x plus 12 minus 1. 9x plus 11. That does not equal x. So no, they're not inverses of each other. That's how you determine inverses. You only put one in for the other. 32 is pretty basic in terms of inverses. They give you the relation negative 8, 6, 4, negative 3, 1, 5. That's the relation. So the x's are negative 8, 4, and 1. The y's are 6, negative 3, and 5. This is the inverse. 6, negative 8, negative 3, 4, 5, 1. Just flip it. That's all you do to get the inverse. That's all an inverse is the original x becomes y, the original y. So now they want you to graph x minus 1 squared minus 3. Okay, and then the inverse on the same coordinate plane. Now, what I would argue for you here is this. My vertex of this graph is 1, negative 3. Right, that's your vertex. And I'm going to go 0, negative 1 for x, and then 2, 3 here. If I plug 0 in for x, 0 minus 1 is negative 1. Negative 1 squared is a positive 1. 1 minus 3 is negative 2. 3 minus 1 is 2. 2 squared is 4. 4 minus 3 is 1. So 1, negative 3. 0, negative 2. 1, negative 2. 3, 1, negative 1, 1. And that's the graph. When I do my inverse, you're simply just doing this. Negative 3, 1. Negative 2, 0. 1, negative 1. On the bottom, negative 2, 2. 1, 3. And we're plotting those points. Negative 3, 1. 1, 2, 3. Negative 2, 0 is here. 2 is here. One negative 1 is here. 1, 3 is here. And that's your inverse graph. It just turns to the side. All right, the growth rate. So we have y equals 2 times 1.42 to the x. This is 34. That growth rate is 42%. It's whatever the number is after the decimal. For 35, you have y equals growth here, sorry. So 35, we want our rate of decay. What did I subtract from 1 to get to 0.25? Well, it had to be 0.75. So the rate of decay is 75%. Hold on, let me see. Spell decay right, because that looks awful. Next 2. $36. Anytime the number we're raising it to, you have f of x equals 2 to the x plus 1, that's growth. When the number that's being raised to the exponent is bigger than 1, that's growth. Which means if you look at 37, f of x equals 1/2 to the x, that's an example of decay. Okay. It's pretty straightforward like that. Number 38. 2 cubed equals 8 in log form. Log base 2, 8, and it's always equal to the exponent. 39, log base 4, 64 equals 3 in exponential form. That's going to be 4 cubed equals 64. And that's our answer.